Hi everybody. Well, here it is, the new bench and our first project that we're going to finish on the bench. And actually it's already finished. I'm doing this video after the fact, and I promise you I will do a proper bench tour when I get things a little bit more done. But I really needed to get this thing finished first because the owners had it sitting here for a while, and I need to get some stuff out of here. There's way too much stuff I need to get back to everybody that dropped things off and so forth. So like I said, I've been so backlogged with projects, I'm not taking any new projects on, and I'm just trying to clear out the ones that I do have and clear out my own projects that I've been waiting to get done. So here it is, the new bench. And we're going to do, in this video, we're going to actually finish this up and see how it turned out. And guess we'll see if there's a few surprises along the way inside there. Who knows? Definitely was one of the more challenging, if not the most challenging, restoration I've ever done. So if that sounds interesting to you, stay tuned and let's get on with the video. Alright, we're on the new bench. This is the first day, first moment here, resuming. I just have this thing back up on here, and I'm kind of looking at the layout a little bit and just kind of deciding if I like it or not, but we'll rearrange things, I'm sure. It's a work in progress. But anyway, I got this up on a bench, I powered it back up, and I found something pretty interesting. The reason I have you zoomed in where we are here, so hopefully you'll be able to see. This tube right here is your first IF, which is the 6SK7. And once again, this is a hybrid schematic. It's got the AM detection of one version of schematic, but it has the front end here, the first IF, of another schematic. So this is the correct. So here's what I thought we were supposed to have. I'll show you right here if we can see it. Probably a lot of glare. Let me move the light. So you can see right here, and the way this goes, you have pin 5 going through the 27 ohm resistor through this cap to ground, and then this goes around and it kind of snakes its way up to the first IF, or first RF. That is not what we have on this circuit. What we have on this circuit is schematic number 2. This whole job is turning into number 2. And you can see it's much simpler. We have pin 5 going through a 270 ohm resistor and this bypass capacitor right to ground. This is the correct schematic. When I went to look at the actual resistor, I'll move the light below and kind of shine it up so you can see. And when we zoom in, hopefully it'll show it. Look at that, up underneath there. You can see it really clearly in this camera. It's hard for me. I have to kind of take my glasses off and stoop down, but that resistor is completely fried. And that's, of course, your first IF, and which is why the IF is not working properly. So I have to replace that before we do anything else. But at least it's something, and this is a good first step for the new bench. So things are working out. So let me get that replaced, and let's see if this thing looks any better, because right now I was getting it was passing an IF signal, but it was really, really noisy, and that's why. All of the offending resistors have been replaced, and you can see the mess down there. And that one was just completely broken. It was in bad shape. All of these were out of tolerance, more than 20%. So they all got replaced while I was in there. And now we have something very different. So if I connect to, this is the output of the first IF. And if you look on the scope, there's just that little signal there. And it's not locked in because I have it. You can see right there. And if I move over to the second IF, and don't worry about that jittering, so here's the second IF right here. She's totally off scale. I have to go way down. And there's your 455 kilohertz. So huge amounts of gain now. That was our problem. So I think now we have an IF stage, and now I can connect the speaker back up, and we can see if we can get it to pass some sound out to the actual speaker. So before I put this back together, I'll give you another update. Right in here where we're focused, this is actually the local oscillator tube. And the front end pretty much has to be installed for the AVC circuit to work. So I did have a IF, but the IF was getting squelched out. After it would be on for a little bit, it would kind of just pinch off the signal. And as it turns out, the AVC circuit kind of loops through the RF, front end RF. So all of these tubes have to be fitted. And if you recall, I did not have local oscillator before. Well, long story short, after tracing it around, you can see this connector right here. I've cleaned it off. There was one of these gigantic orange drop capacitors in here, this one, along with a 1K resistor, which was reading high. And both of those went from this pin right here over to here, to this pin on the local oscillator. The problem was there was a gigantic glob of solder right here. And if you look, this coil is right here, and you see this big, thick winding. This is like it's not a wire, it's like almost like a hollow tube. It's one turn around this core of this little coil, and that big solder blob was actually stuck between the pin and this big thick wire here, and it was shorting it out. I think that was another problem with the front end of this, why it was not working so well. So I had to clean that all off. And another thing was there's a tiny winding, and it's wrapped over this core along with this big one here. And you can see the wire here. I just put it back on the pin on this wafer switch. And now I have to install a new 1K resistor. And I'm going to put a smaller film capacitor, mylar capacitor, I'm sorry, like this. I'm going to put it in there. Hopefully everything will fit better and it'll work. I don't know if this is going to fix the problem, but each time I find one of these things, it makes another part of the receiver work, at least work or work better. So we're getting closer, but we're dialing it in a little bit at a time. Ain't that just the most beautiful sight you've ever seen? So that's a 455 kilohertz with a modulated 400 hertz tone on it being injected into the input of the mixer oscillator. So that's right here. So we're putting the signal right there. It's going in there, and it just looks beautiful. So we still have some issues with the amplifier, but that might be the matching transformer I'm using with the speaker. I don't know. I'll look at that later. But I think we're ready to go now, go back into the circuit, go back this way, and start seeing if we can get some RF to go through the receiver. Well, right there, I'm driving a signal right into the antenna input. I'm on broadcast band, and if I turn the tuning knob, you can see I'm at 1 megahertz broadcast band, and you can see I can tune right through it. And looking at the dial indicator, I'm almost right on. Yeah, I'm almost right on 1 megahertz. So it's pretty close. Now, the receiver is totally deaf. In order to get that signal to show up there, I'm driving about a 3.8 millivolt signal into the front end. It should be microvolts, not millivolts. Now, that being said, I have a fairly decent sized isolation capacitor in there, but that shouldn't attenuate the signal that much. So it's working, but it's very, very deaf. So we have something to work with now, at least, and that's a good thing. And I can shut the modulation off, and you can see it's kind of really bouncing around a lot too. It's noisy, but those kinds of things we can take care of as we move along. And there's our modulation, and you can see if I even go down to one millivolt, I don't get much signal. So, and you just hear it coming in now, but now I'm driving 12 millivolts into it. So yeah, we're close, but still have a way to go. Getting into the amplifier section now, it does not match any of the schematics. All the schematics have the amplifier, well, pretty much the same. And what we have is right here, there's a 1200 ohm, a 56 ohm, and then a 10K, and then this 10 microfarad bypass capacitor. And if I look here, I have the 1200 ohm, and the 1200, there's that 10 microfarad capacitor, but it's not correct. We have the capacitor here, and that should be 10 microfarads, but it's not. This actually is for the outputs, but more importantly, this bypass cap is not here, but it might be, there might be a wire under here going all the way up to that CAN capacitor, so I'll have to look at that to verify that it's correct. Then you have a 56 ohm resistor going to ground, and that's what's kind of setting up the bias for this section. And when I look at it on the meter, if I go from down here to up here, yeah, my 56 ohm resistor is 144 ohms. It's turning out that not all but most of the resistors in this receiver are way out of spec. And there were a few that tested out good, and I left them in there. They're still really good, but there were quite a few that were bad, and this is just another one. You can see the pile down here that I have. If I move over, you could see, and this is just today. I've been doing this ever since this thing hit my bench on the old bench. So I'm going to replace that 56 ohm. I'm going to check the capacitors to make sure they're correct. And then the other thing that I noticed was where we come out of pin 4, it goes into a 220K, goes up through the headphone jack and all that. And then on this side, it comes out and goes through a 2200 and then a 220K. And then that kind of splits off, and you can see here's your where your cathodes tie together for your outputs. So this is your output to ground here, and then this shares the ground here. But this should be a 2200, not a 220K. And if you look here, they have both sides, they replaced these resistors, but if you notice, they're both 220Ks. They're not correct. So there's some things that's not right in here. We're going to have to redo all this and fix it. So I'm going to rewire it according to the schematic, and then we'll be back. Okay, amplifier is now working. And it's really clean, sounds really good. So I think we're good with that. Now we got to figure out how to what's making this thing so deaf. I can tune in, if I inject a really strong signal, I can tune it, but it's the AVC squelches it out after a couple of seconds, and I don't know, and it's very weak even when it is coming in. So I don't know, do we still have a bad tube? Do we have an alignment issue? Is there something miswired? Do we have another bad resistor? Who knows? But we just have to keep plugging along. Well, we have it figured out. We have a bad sensitivity pot.
Guys, thank you so much for being part of Radio tonight. You making Pittsburgh as well. Thank you. Excellent. Everybody, we're taking a quick break.
There you go. I just have an antenna connected and it's working.
Like this, I swear.
This pot needs replaced. Look, I just touched it. I lost it.
Check out our new website at htech.org, full of all kinds of resources. Be a member like these folks here at a
now,
and you can really make...
My thought on this is probably it could be that it just got sprayed one too many times. A lot of times these old carbon pots, if you spray them too much with, especially with really caustic things or with very oily substances like deoxit, and you soak it too much, the carbon track will actually delaminate from the actual wafer board in there, and it ruins the pot. So that might be what happened here, or it may have just worn out with age. But whatever it is, we need to get it replaced. Okay, this is absolutely horrible. You don't hear me say that a lot, but this is horrible. So what happens is when you adjust the sensitivity, if you turn it all the way to 10, all the way to maximum, which is supposed to be maximum sensitivity, what you're doing essentially is you're taking this pot and this wiper and you're driving it all the way to ground, all the way to chassis ground. And it does. Now I removed the leads from the pot and I measured it, and there's nothing wrong with the pot. It's fine. So if you just move it the tiniest little bit off of maximum, like from 10 down to maybe 9, the sensitivity comes way up. Then as you rotate through the range, it kind of drops back out and comes back in again. It's really strange. It doesn't work like any sensitivity control I've seen on any other Hallicrafters receiver like this. Now, if you follow the wiper, it goes to a couple different places. And it depends on what model of receiver you have. So, for instance, this one, you have, it comes off of the wiper, it goes up, over, and to the second RF to pin 7, and it should be a 150 ohm resistor. Likewise, it goes across this way, and it goes up through another 150 ohm resistor to pin 7 there. So if I clip onto the wiper of the pot, I should see on pin 7 of either of the RF amplifiers, I should see 150 ohms. So we're now connected to the wiper of the pot, and it's morning. I'm having my cup of coffee here. So, and you're not going to be able to see all this at once, but I have the tubes removed from the sockets. And if I go up to pin 7, let's see if I can hold all this. On the first one, we have pretty close to 150 ohms. It's 144 ohms. If we go over to the second RF, if you notice, that resistor is reading really high. It's 246 ohms. So you might say to yourself, well, maybe it's a 250 ohm resistor and it was a mod. Well, it's not. So that first resistor that we were looking at, if you take it up to here, it is buried way back on a terminal strip down in here. Downside, you can't even see it from here. If you look at just the right angle, sometimes you can kind of see it from the other side, but it's very hard. There's a terminal strip right there, and it's in there. On this one, it's even worse. On the second RF, here's your coils. There's a terminal strip behind this coil, and you can just barely make out a 150 ohm, or there it is, brown, green, brown, 150 ohm resistor. It's reading 244 ohms, so it's way high. To make matters even worse, there are two schematics I'm using on this. Sorry, this one's upside down. I'm using this one, which is the, I don't even remember what number it is. And I'm using this one, which is the 89D210-D. And this one, I forget what it is, but oh, there it is. It's the 89D257-F. And believe it or not, this radio is half and half. So for instance, a lot of the circuit is similar to the 89D257F. However, when you look at these 6H6s, you notice one section of this isn't used at all. But in this section, it is used. Has to do with the noise limiter circuit, and the AM detection where they're doing it is different between this one and this one. Well, I have this circuit for here, but I have on the RF section, I have this circuit for the RF section. And likewise, on this circuit, this on your second IF ties through a 330 ohm resistor and goes back to the sensitivity control. But in our radio, that's not the case. We actually have the second IF going through a 220 ohm directly to ground, which is what we have here, which is, if you look, right here's a 220 ohm resistor. It goes directly to this ground terminal and goes to that pin 5 right there on the second IF. So you can't, there is no schematic you can follow for this. You just have to compare it and figure, you know, it's like somebody at some point in time modified this radio partially along the way, but it is not any one radio. And that's what makes this extraordinarily difficult. And the thing is, you don't know what those modifications do to the rest of the radio and how it performs. If the upgrades were not performed properly, then there's a really good possibility that this thing's just never going to work right. It does seem to be working mostly, but for instance, that sensitivity control is a big issue. Now, it could be that one thing where all the schematics agree, this is always a 150 ohm resistor. There is a 150 ohm resistor in there. It's reading 244. So that's one thing that could be a problem. But whatever it is, this just does not like being driven all the way to ground. It causes problems. I did replace this once again with a 100 microfarad capacitor. I looked at some pictures. I looked at another example unit. All of the ones I've seen, it was a big 100 microfarad paper electrolytic capacitor. So as you can see, I did replace that with a 100 microfarad electrolytic. And even though this orange drop is absolutely massive, it's just a 0.5 microfarad. So for some reason, that's how they did it. They bypassed this electrolytic with this film capacitor. And that's how they did it in the schematic here. So that's how we have it. For the amplifier, I know I didn't catch you up with that either when I rebuilt it. As it turns out, this section here that I thought was incorrect was correct, because there's a wire that comes off of this terminal down here, and it loops all the way around to this terminal, and there's your bypass 10 microfarad capacitor, and then it comes back to here and then snakes its way back up through this 10K resistor. It matches the schematic. It's just for component layout purposes. I'm sure that the 10 microfarad that was in here originally was much larger, which is why they couldn't have stuffed it in this area here. So I'm pretty confident that this is okay. So I left it, and it works. The amplifier is working perfectly now. I've verified that even though the wiring goes back and forth and zigzags around and looks really strange, it is anatomically correct with the schematic. So it works. Now, we have to get control of this sensitivity, and I have a feeling if we solve the sensitivity control problem, the rest of this receiver is going to work perfectly, and it's just going to be a matter of touching up the alignment, which I don't think is that far out. We rebuilt a couple of these IFs because some of the mica capacitors were not correct, and they are now, but it doesn't seem to have knocked it off by as much as you might think. It's actually just going to need a little touch up. Because this has that crystal filter, we'll have to do that thing where you determine your IF frequency based on the sweet spot of that crystal. It's just a trick that you do with these Hallicrafters, and that's not unique to the SX42. A lot of the ones with the crystal filters have this, so we'll go over that later. But we're very close. I think if we solve this last problem, we're going to have a working unit. Well, the plot thickens. So I'm now on the first IF, where, so we said earlier, in this schematic, the sensitivity control goes to the first IF through these two resistors and up to the S6SK7, whereas on the other version, it comes off of the sensitivity control, goes around, and it goes to the, if you can see there, goes to the second IF cathode. So it depends on which version you have as to which cathode. So we know we don't have this one because there's that 220 ohm directly to ground right here. And so then we would think that we would have this right here. Well, when I go here, here's your 270 ohm on the first IF. But if you follow how it snakes around, it comes off of pin 5, and you can see these two, the capacitor and the resistor. This cap goes to ground. This resistor goes to this terminal, which jumpers through this wire to here, and to ground. So essentially, this is just going directly to ground. It doesn't go to the sensitivity control. And lo and behold, if you go to the very oldest SX42 schematic, which is schematic number 89D210K, sure enough, in this version, both of them go to ground. And the sensitivity control only seems to go to this one up here through this 150 and this second 150 right here, and that's it. It only goes to those two controls there. And it does not, if you notice, it does not branch off and go down into your IF section. I hope I was on camera when I showed you that. So we actually have the sensitivity circuit from the very oldest schematic. I don't know how anybody can work on these things. I really don't. It is so difficult. This is the last SX42 I will ever service because of this. I guess if you really wanted to be an expert on these and you've worked on them enough that you were familiar with all of it, you could do this. But if you're not, this is not really your wheelhouse, probably not something you would want to tackle on your own unless you really want to do a lot of research up front. I'm learning that. Okay, I'm starting to understand what's going on here. And you'll have to excuse the microphone because my microphone broke and I'm back to the other one that's mounted on the camera. So and the camera's not facing me that well. And you got to forgive the lighting because this is just kind of a makeshift setup. But what they're doing here, this 100K resistor is connected to the B+. So if you follow it back, it comes along here and it goes down to the B+, the unregulated B+, right off of the 5U4. So you're essentially taking 300 plus volts or whatever, and you're running it through this 100K resistor to the center tap, or to the wiper of this pot. So when you turn the sensitivity all the way down, or all the way up, all the way up, you're essentially squelching that voltage out to 0. So there's no voltage here, which allows this cathode right here, so here's your cathode, or your actual control grid and cathode are tied together, see that? You're grounding your cathode through a 150 ohm resistor on your RF amplifier. And in the later models, you're even doing that with one of your IF circuits, so they're actually adjusting the bias on these tubes. And what they're doing is, if you turn the sensitivity down, rotating the pot down, or counterclockwise, I should say, brings this resistor up, which allows this voltage to influence here. So you're taking a positive voltage and you're applying it to the cathode of these tubes here, which is changing the bias and making it less sensitive. So that's essentially what we're doing. So you're reducing the gain of the circuit. For whatever reason, it is very unhappy when you run this all the way. In other words, when you're grounding these two resistors, these two grids, or these two cathodes directly through the resistor to ground, the circuit is unhappy. I don't know if there's a voltage that's incorrect or what, but you have to have just the tiniest little amount of voltage here, or the sensitivity goes completely in the dumps. So that's not right. This circuit should be biased in such a way that it has its maximum gain when you have this 150 ohm resistor to ground in parallel with this capacitor, or I should show you over here, this capacitor. Remember, this doesn't exist on ours. It's like this model here, which is this model up here. Isn't this awful, trying to follow all this? So essentially, there is no path to ground for the cathode except through the sensitivity pot. And when and because of the way this thing's working right now, if you don't have a little bit of voltage here coming from your B+ through that 100K resistor and through the pot, these lose their sensitivity. In other words, they lose their gain totally. So there's something wrong with the circuit. It should do the opposite, but it doesn't. So it means there's something wrong up here, and we don't know what it is. But I think, again, I don't know if this problem existed when the owner had it, or if this, and he just dealt with it. I don't really know, but it's definitely not working right. So we have to find out what the bias point of these are supposed to be. Luckily, we have the old circuit, so these are like this. They're not influenced by the sensitivity pot. So everything's happening up here in the RF amplifier section, first and second RF. So that's where we're at. I now have the meter connected from ground to pin 7 of the first RF amplifier, and that should be, when it's turned all the way down, we should be reading through this 150 ohm resistor, through this, over to here, up through here, and through the wiper and directly to ground, because when we turn it all the way up, remember, it's making the pot go down in resistance. So with the sensitivity at maximum, I should read 150 ohms. And you can see I have it set to maximum. And I do not have 150 ohms. I have 300 ohms. If I turn the sensitivity down, you can see I'm moving it. Right now it's at 9. And it moves very smoothly as I reduce the sensitivity. And the resistance will go up to about a maximum of 10K, which it should because it's a 10K pot. So that makes total sense. 10K plus the 150 ohms. But when we go all the way down, it's still a little bit. But I believe the problem that we're having right now is that right about here is where it starts to work, at about 500 ohms. And we don't know why that is. Now this with all the way up, it's probably because this pot, these pots don't always go all the way to ground. Some of them do, some of them don't. We could measure that. But neither here nor there. It seems like until we get to about 500 ohms there, instead of 150 ohms, that's when you're seeing the problem. The other thing is I should probably zero this meter out. Let's do that real quick. Make sure I didn't mess up on that. So connect that. Yeah, see, I'm off a little bit. You got to remember to zero the meter when you're using these old analog jobs. Okay, let's measure it once again. Make sure this is correct. Okay, so all the way down, yeah, there you go. It's a little bit over 200 ohms. And if you remember, we were reading 244 ohms, and I don't know why that is, because I did manage to get in there enough to measure that resistor, and it seems to be measuring 150 ohms, but I'm not sure. It also could have something to do with, has nothing to do with the switch, so I don't know. Regardless, that's right about where you want to be. So who knows? Unless that was a special pot, I don't know. Okay, I have the IF amplifier, or the RF amplifier tubes pulled, and listen. That sounds like a silver mica disease on something. And it gets worse depending on where you put the sensitivity. And you can see as I rotate the sensitivity control, the voltage goes up, and it goes between 0 volts, roughly 0 volts, and about 22.5 volts. So there's minimum sensitivity, and there's maximum sensitivity. And of course, it has no influence right now because I have the two RF amplifier tubes removed from the sockets. And you really shouldn't be hearing this noise. So this is coming from probably from the IF section. So we have a problem. Okay, we have the noisiness. And when we remove the mixer oscillator, noise goes away. So that tells us our problem is somewhere up here, which is the worst place it could be. Now, it could be this tube, but this is a new tube that I had in stock. It was brand new in the box. I have about 4 or 5 of them I found, and I don't think it's bad, but we'll try a different one just in case. But I think there's something wrong with one of the silver mica capacitors is bad. Okay, I have a new old stock Raytheon as well as the Philco, and it's in, and you can hear no change. So it's definitely something to do with a capacitor or something that's, or possibly a noisy resistor. Those carbon comp resistors can do this as well. Well, after completely rewiring that circuit, because 2 of the resistors were noisy, and the worst one of them all was a 2.2 meg, if I can find it laying in here someplace. Where was it? It was a 2.2 mega ohm resistor, and you can see the new one, that little blue one down in there, I replaced. It was way off. It was reading very low. It was only reading about 1 point some meg, and it was noisy. And this 47 ohm resistor was also a little bit noisy. Both of them, replacing them, improved quite a bit. The mica capacitor was good, but I replaced it because I was in there already. Everything else is good. It's now quieted way down. It's good. And you can hear,
Just want to know your options.
it's working really well. But here's the thing. Looking at this, again, at this sensitivity control, if I turn it all the way up, it gets a little bit quieter. If I just back it off, here, right there, it drops off. Then it comes back in. It's not the pot, it's not the voltage. And if I go a little more, it gets louder, then it starts dying down again. So what that tells me is that biasing of these two RF stages is still wrong. So we still got to figure that out. But we're getting so close. Now another issue I'm noticing is this is the AVC control. It's off. This is the noise limiter. It's on. Watch this. If I turn the AVC on, it drops quite a bit, which I think that's a little too much. But more importantly, if I turn off the noise limiter, hear that? I don't know. And it doesn't work.
Or call toll-free.
So the AVC and noise limiter circuit still has some issues as well. Wow. What else could be wrong? Boy, I shouldn't. That was a rhetorical question. Okay, so the good news is we're making progress, like I said. Okay, so here is the noise limiter that was not working. And you can see now it actually does its job. And what it ended up being was a couple different things. The first thing was, I can't adjust my camera. Here we go. So the first thing was 2 out of tolerance resistors. They were pretty bad. And then up here, this 2.2 mega ohm resistor was in the terminal, but it wasn't soldered. It was just laying in there. It wasn't hardly even touching. It was just kind of floating inside the eyelet. So I soldered that down and replaced those 2 out of tolerance resistors. Now it's working perfectly. And the AVC is working. Everything is working. Now that this thing's generally working, I thought I would remove the volume pot and service it. And I took it out and just cleaned it with just basic cleaner. I didn't even use deoxit. I'll put a little drop of the deoxit D100 on there, and that's it. But you can see it's still in very good condition. The switch, if you remember, we had to jump her out. It wasn't working. And to fix that, you have to remove the switch from the back of the housing. So here's the back of the pot housing. And the switch kind of goes in like this through these little tabs. And you have to remove it from here, because the stuff you need to clean these contacts is really, really strong. And what I use is CRC, and it's called Electra Motive. It's electrical parts cleaner, and it's designed to be sprayed directly onto like motor armatures and so forth. And it is non-conductive, but it is extraordinarily caustic. It will eat. If you get even a drop of it on this carbon, it'll just eat the carbon right off of the board. So you do not, nothing plastic. But you can actually take it and spray it right inside here, which is what I did, and then work it back and forth a few times. and you need nitrile gloves. If you use vinyl gloves, it'll just dissolve right through them. It's nasty stuff, but it cleans it perfectly. And when it's done, this switch is perfect now. So we saved it. We're going to put it back together. And amazingly, we're even getting FM, even though the discriminator's way out of whack. It needs aligned, but we're getting FM. Not super sensitive, but it works. All the bands are working. It just shocks me. I can't believe it. So for the alignment, here's the scenario, some things worthy of note. First of all, the RF section of this seems to be spot on. So it looks like all we're going to have to do is the IF section. Now I have the radio turned on and warmed up, and the intermediate frequency or IF alignment on this, you have to do it with the case off. When you have the case off, this front plate is loose, and it'll kind of, the weight of the radio will actually bear down on it and cause the tuning knob to jam up. So you have to put a little clamp or something to kind of hold it steady on there, and make sure you put a little piece of paper or something on your clamp so it doesn't scratch the face. Now when you do the RF alignment, you need to have the cover on, and there's access holes for all the RF alignments, but it doesn't look like we're going to have to do this. So in order to be able to get in there, you have to take the cover off, and then they want a 0.1 microfarad capacitor, and they want it attached to pin 1 of the mixer oscillator, the 7F8 tube, and then they want you to drive it at 455 kilohertz with your signal generator, and they just want enough signal to be able to hear something. And I know that the IF is out of alignment because I rebuilt the transformers. They have different capacitors in them, so it's invariably going to be off. And this, I have a feeling this radio is really going to wake up once we do this. On the output, I've disconnected the speaker, and I have a 470 ohm dummy load, which is similar to a 500 ohm load for the transformer because it's that funky high impedance output transformer. And then I have my voltmeter connected across it, and you can see right there. I could also use the VTVM, but I'm just going to use this so that you can see it. It's just more convenient here. And all we're going to do is we're just going to turn all of the IF alignments and see if we can get this thing to go up. So what I'm going to align, what I did to make it a little bit easier, if I can get this stupid thing to loosen up. If you look over here, I just went and marked all of the 455 or the 455 kilohertz IFs with a black dot, and it just makes it easier to find them. So we're going to align this one, then this one, then this one. Then we're going to go on the opposite side of the transformers and align the same spot underneath. And you can see them. There's this one, and that one. So it should be pretty easy to do. I'll get you back on the meter here so you can see what's going on. Sorry about all the bouncing around here. Okay, so you can see we just have a little bit of signal there, and I'm going to turn the first one. We'll see what happens. Wrong way, of course. And look at that. Okay. All right, that's the first one. Okay, and the second one is really covered with glue, so I'm going to have to clean the glue off. I'll be right back. Okay, the glue is cleaned. Unbelievably, this radio has never been aligned. Oh, there we go. Wow, that really woke that one up. Okay. And here's the third one. That one's right on. Look at that. Okay. All right. Now we'll do the other side. Oh boy. That one was way off. Doesn't surprise me though. All right, I'm going to go way down here. Can't get on that one. Okay, I think I got it. Oh yeah. And that one wasn't quite as bad. It was off a little bit. Okay. And let's check the last one. And that one was pretty close as well. Okay. Boy, that really woke that one up. So after you do the regular IF alignment, that just kind of gets things ready to do the real IF alignment, which is done with the crystal phasing selectivity knob. Crystal phasing is something a little bit unique compared to what you usually see on an AM receiver. And I think you can just see it here. This little box here. Some of them are black and white, some of them are brown. But this is a crystal filter. And this crystal unit actually has a set peak frequency. And it's different for everyone. When they cut these, they get them close, but they're not perfect. And what you have to do, and that's what this procedure is all about, is you have to determine what that peak frequency is, and then you're going to adjust the entire IF section to that specific frequency of this specific crystal. If you were to replace this crystal with another one, even if it was brand new or if it was out of another one of these radios, it would have a different frequency. Now, it's not way off of 455 kilohertz, but it is off. And if you look at this one over here, you can see this one. I don't know if the camera can see it or not, but 454.6 kilohertz is what this one is happy with. Now, if you notice, I had to break out some old technology here. We got the old style generator, and the reason being is in order to do this adjustment, you have to be able to rock the frequency back and forth. And that's not so easy on some of these newer design synthesized signal generators, because of course you have buttons, and even the one over here with the knob, that knob is nothing but, like, when you rotate it, it's a digital knob, and it can't smoothly vary the frequency up and down in an analog manner. No matter how you set the steps, it's just never right. It's very awkward. So you have to have an old school signal generator to do this properly. Now, I already did this alignment. It is very, very difficult to do, and that's why I had to do it off camera. But if you look, here's the final result, and you can see how nice that sine wave looks now. And that's a 1 kilohertz modulation, and the radio is very, very sensitive now. But what you're going to do, I'll go over it with you. So what you do is you do the first step just like we did earlier in the last clip. You set up your 455 kilohertz. Then what you're going to do is we're going to go to crystal phasing, broad crystal like that, and they want you to switch your modulation off so there's no modulation. See, I just turned it off. And they have you go in, let me move this light. They have you go in and turn on the BFO. And they want you to just put a frequency up there. And yeah, it's jittery. I know. So you're going to set that, and it's going to create a beat frequency. And what we're going to do is, if you notice down here, it would have been tuned to 455 kilohertz, but I've already set it. And what you're going to do is you're going to rock the signal generator back and forth until you get that null point. So I'm now above my frequency, and there it goes to 0, and then if I keep turning it goes back up. You see that? So there's like two peaks, and there's a null point in the middle. And the thing that confuses everyone is, remember, you have another oscillator, the BFO, the beat frequency oscillator, and it's actually putting a frequency that's about 1 kilohertz or whatever you set it off of the frequency of the actual signal generator. So really what you're doing is you're using that BFO, and you're actually using your signal generator to determine the exact frequency that crystal resonates at, where it's happy, where it'll pass frequency, not resonant, but where it will pass the frequency through. And once you do that, wherever it nulls out like that, you look down at your frequency, or at your signal generator, and you take note of what the frequency is. So in this case, it came out to be 454.6 kilohertz. That will be the new IF frequency. And what you're going to do from that point on is you're going to adjust all of the different stages for sharp, medium, and broad, and you're going to re-peak the entire IF section to that in my case, 454.6 kilohertz. Once you do that, everything should kind of fall into place, and what will happen is, no matter whether you're using the crystal filtering or the other the standard selectivity knob, both of them should work pretty equally. And more importantly, you should be able to, when you go into the crystal phasing, you can use this phasing knob right here, and you can really fine-tune that station and kind of tune out all the background noises and things. It works really well, but it's very difficult to do, and the instructions are next to impossible to follow. It's very confusing the way they explain it. The instructions don't tell you when to turn the modulation for your signal generator on or off. They kind of assume that you know what you're doing, and they're kind of like shorthand notes instead of detailed instructions. So, and it can be very fiddly, because you can be halfway into it and something can drift. You have to go back and start over again, and that's why it's really difficult to do on camera. But that's the gist of how it works. This one's set up very well. So the only last thing to do would be the IF for the 10.7 megahertz, which will be for the FM and the higher bands, the VHF band, and then to adjust the discriminator for the FM. Those are very easy. The IF is very simple. You leave everything as is, leave your signal generator, everything hooked up the same way, except you just switch your band up to the high band, and then you go to 10.7 megahertz with your signal generator, and you peak everything. It's pretty simple. And then for the discriminator adjustment, it's not that difficult either. You basically put a modulated FM signal in there, which I don't have my FM signal generator hooked up right now, but you put an FM signal in there, and then you look at it on your oscilloscope, and it would look very much like into here. It would look very much like that. And what you'll see is if your discriminator is not adjusted properly, either the top or the bottom would kind of distort. It'll kind of garble up and look bad, and you have to adjust it to get it straight. Not that difficult. But anyway, it's done. We're going to try. Oh, and by the way, there was one last mistake I found in this thing. And I don't know if I put this mistake in or if it was in there, but when you zoom way in down here, you notice this resistor that's right here. That's a 1K resistor, and it actually had a 100K, and I believe that 100K was in there. I didn't change that, and I don't know who put it in there or why, but I actually took my SX42 apart and looked at it just to compare, and I can show you the picture of mine inside. Okay, sorry, that's a 1.2K. If you look under there, you can see the brown, red, and red. And you can see on this picture here, if I can get you zoomed in where you can see it, right there. I don't know if it'll show you, but you can see in the camera here on my phone, it's a brown, red, red on my other radio. So I don't know why that 100K, but that fixed all the problems with the sensitivity knob not working. I knew there was a voltage not correct in there, and sure enough, pin 5 of that second RF tube would have the correct voltage when you started the machine up, but as soon as that tube warmed up and started to conduct, the excess current draw through that 100K resistor would cause it to limit the current, and the voltage on that tube would go from 230 volts all the way down to about 15 volts, which was causing our deafness of the radio. Now that it's in there correctly, it's really, really sensitive now. So again, who knows? We'll just chalk that up to, I don't know. This thing was just loaded with problems. I've never seen a radio with so many problems. I just think it had been touched by so many hands and modified by so many people that it just had a lot of problems. But let's get it put into the case and see how it performs now. Okay, we're all together. We have the S meter adjusted. We have everything up and running. And we're just looking at broadcast band right now, and there's no need to do the RF. They were all of those were still sealed. They have not been touched. The capacitors in that section have not been touched, and it's spot on. There's no need to do it, but it's tedious and long to do it, but it's not hard. You just feed different frequencies into the antenna terminals, and you put it, set it on the frequency with the dial scale, and then you tweak the adjustment until you get the strongest signal. So that's easy to do. Anyway, here's AM, and you can hear how quiet this is. Listen to that in between stations.
We're all feeling the weight of COVID.
Near you today. To learn more about cool things to do in the forest, visit
Wow, there's a close station. I mean, this thing is just wicked sensitive now. I mean, I'm in the basement here, and there's all kinds of noisy equipment.
And those are the type of players that probably will not opt out.
And it just keeps station after station. Let's go see if we can get some shortwave. Well, there it is. That was easy. Now we're getting up at the top scale.
Life, for my sake, and the gospel shall gain it.
Some digital stuff. The aliens. I'm not even using the band spread, and I'm picking all this up. Okay, we got short wave. Let's go over to the FM band. And there is something in this basement that is putting out a terrible interference, and I'm not sure what it is. It sounds like something, you know, some power supply somewhere, but it wreaks havoc on this receiver in the FM band. Although I found we can still receive things. I just can't get anything very strong. But
At discover.com.
When everything is changing, you need a store that's a constant. A store that has the brands your family loves and the value that you need. A store where you can stock.
not bad. But you could see it works. It's just I have some really bad interference down here for the FM. Who knows? I could go around turning things off and eventually get it to show up, but who knows? Anyway, it works, and it works really well. That was quite a journey. This was probably one of the more difficult repairs I've ever had to do, and I think we all learned the lesson from this, that an SX42 went through a lot of changes during its production runs, and a lot of people out there, some of them were Hallicrafters service people, some of them were not, and a lot of the mods got put into some of these receivers but not documented, and when you're done, there's no one schematic that matches your specific receiver. And from what I read and what I hear, that's pretty common with these. You just never know what you're going to get. Mine is similar to this one as far as vintage goes, and it does have some of the differences, but it does have the 6H6 that both halves are used instead of only one half being used. So that means it's probably one of the older models. But again, who knows? So anyway, this works. The only thing left is the two side rails that kind of support. There's four screws that go in here, 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 and here. And there's these sloped side rails that attach the chassis to the front faceplate. That'll keep it from racking in there. And I know the owner has it, but I didn't get it out. I even saw it in his car when he brought this to me, and I didn't bring it in. I left it with him, so we'll have to put those side braces back on, but that's fine. But the radio works, and I think we're going to have a very happy owner, because I think he was a little bit worried for a while there. So what do you think? This was the first project for the new bench, and I will be doing a tour of the bench, and it's probably going to change because, of course, you have to use the bench to kind of know how things work and if you can see things properly and if it's convenient, or ergonomics and all that. So that'll be all, it'll evolve. It's a work in progress, I guess. But we'll talk more about the bench in another video. Until then, you know what I'm going to say. I wish you all peace, joy, happiness, and good health in your lives. And I thank you for coming along. And if you hung in there with me on this whole big video, wow, you must really like these old Hallicrafters radios. Anyway, that's it for now. I have a ton of projects to do, so there'll be a lot of things to see coming up. And I hope you join me for all of them. Take care and stay well. Bye-bye.